Okay, so for today, we are going to look at what are the rules and regulations from CIE that's want us to follow to draw the line graph. Okay, so now before we start how to draw the line graph, I'm going to do a simple comparison between the line graph versus the bar chart. These are two main kinds of the graph we are going to draw in paper 3 or our practical paper. Okay, so how you compare? Always we compare independent variable first. We look at independent variable. Okay, we compare independent variable. So what we compare? We compare independent variable whether they are continuous variable or discontinuous variable. Are you clear? So either continuous or discontinuous. Now, what's this mean? If continuous means something that we can measure, means that they have the intermediate. Okay, discontinuous variable means that we can't measure. So what are the continuous variable? For example, temperature. Okay, we can measure temperature. Okay, we can measure the mass. We can measure the time. So those are the continuous variable. What are discontinuous variable? Discontinuous is something that we can't measure. So for example, sample. Sample 1, sample 2, sample 3, sample 4. Okay, for example, we do not know group 1, group 2, group 3, group 4, for example. Gender, male versus female. Okay, for example, species of animal. Okay, cat, dog, humans, plant species. So therefore, okay, or different parts of organism, for example, leaf versus the root versus the stem. So those are discontinuous variable. Okay, so when it comes to continuous variable, always remember we use line graph. Are you clear? We use line graph, but for discontinuous variable, we use bar chart. Are you clear? Another one is histogram. I won't talk about histogram at this moment. Okay, yeah. So basically, we have line graph versus the bar chart. How we differentiate between them, we always look at the independent variable. So the independent variable is a continuous variable, something that can measure, line graph. Something that you can't measure, bar chart. Okay. So in line graph, then we have to follow this rule called OSPL. Okay, in line graph, we need to follow this rule called OSPL. O, S, P, and L. Now, what's O? O stands for orientation. Okay, orientation basically means that you need to know what is for x-axis, what is for y-axis. So always remember x-axis, we label it for independent variable. Okay, something that you fix. For example, I want to know the effect of temperature onto the rate of reaction. So my independent variable will be temperature. Cannot. Why? Because I said, okay, 0 degrees Celsius, 20 degrees Celsius, 40 degrees Celsius, 60 degrees Celsius. So I set it first. And then I measure what they respond. Right. I measure, like for example, I start with 20 degrees Celsius and look at the rate. Oh, so low. And I increase to 40 degrees Celsius. I look at, oh, very high. So it means that my independent variable must be labeled at the x-axis and y-axis will be for dependent variable. Okay, so what is the rule? So this is the first rule of thumbs, very easy. X-axis, independent variable, y-axis, dependent variable. And you have to know that generally, I don't say 100%, generally, because in the requirements from our CIE, you can see that in our table, left-hand side normally is the independent variable, right-hand side will be dependent variable. So means that this one, you use it for x-axis, this one you use it for y-axis, general guideline. Okay, so what else we need to to aware, in this case, you have to copy the title of the independent and dependent variable, and also if the units must be there and must be exactly, you copy exactly. Are you clear? For example, the unit is millisecond, then you don't put it as a minute, you don't change it. Are you clear? So you copy the title or the heading here, independent variable, dependent variable, exactly. Okay, the unit also must be exactly. Are you clear? If the unit is mole per dm cube, don't actually go and change it. Mole per dm cube also same as molar what? Like for example, volume cm cube also same as ml what? Don't. Okay, don't go to actually go and change it. You copy exactly, then you will get the marks. 1 mark for orientation. Okay, so what is this 1 mark for? 1 mark actually for correct labeling of the x-axis and y-axis together with the correct name of the title for the x-axis and correct title for the y-axis with the correct unit. Are you clear? So you copy exactly, then you gain the first mark. Okay, second mark. What is the second mark? Second mark is called skill. S stands for skill. So what is skill? Skill basically means that you want to make sure that when you plot the graph, you occupy at least 50% of both axes. Are you clear? So it means that if I give you the graph, okay, later lah, huh? If I give you the graph like this graph paper, so it means your skill at least have to cover more than at least 50% or more than 50%. Are you clear? So it means that your graph, okay, at least cover about 75% of your graph paper. Are you clear? Means that you have to make sure it's large enough. Okay, but not too large until you can't actually draw all your graph, and also not too small until you only use less than 50% of the area. Okay, so this is one. So how you do this? So we always use this rule of thumb called 1 to 5 rules. Now, what's 1 to 5? Now, because our graph, if you look at the graph paper, in the Cambridge exams, okay, the graph paper, it will, okay, something like this, okay, okay, if you focus at one box here, okay, I call one box like this, I will circle here. So this one box actually is 2 cm by 2 cm, okay, and these 2 cm are divided by 10 boxes, so means that each small boxes here will be 2 mm by 2 mm. Are you clear? So I'm going to talk about this by the 2 cm. So means that when you want to put a scale, always remember 2 centimeter to 1 unit allowed. 2 cm to 2 units allowed. 2 cm to 5 units allowed. Are you clear? But if you say 2 cm to 4 units, no, 2 cm to 10 units, yes, because any 1 to 5. This 1 to 5 doesn't mean that must be 1, 2, and 5, but it can be 10, 20, 50. It can be 100, 200, 500. It can be 1,000, 2,000, 5,000. It can be 0 0.1, 0 0.2, 0 0.5, doesn't matter. So you follow the rules 1, 2, 5. Are you clear? It's either tenfold, every tenfold, or you divide by 10. 1,000, doesn't matter. 0 0.01, 0 0.02, 0 0.05, doesn't matter. As long as you follow this rule 1, 2, 5. Are you clear about this? Okay, then third, I mean, the point here to gain this, and you have to make sure that, okay, whether you need to start from origin 0 or not. Whether you need to start from origin 0 or not. What else we need to focus here? We need to know that your scale have to cover the entire graph. Okay, cover entire graph. I will tell you what this mean. Okay, and last, decimal point. Decimal point, you have to follow the table again. If the table show you 2 decimal point, I will write 2 decimal point. If the table show you 1 decimal point, then I will write that 1 decimal point. Okay, so let's see. Okay, we try this. Now, first of all, let's say I give you this data. Okay, so pH, for example, then this is a time taken in second, for example. Okay, so I have 5 data here. So pH, I choose a 9, 10, 9.0, 10.0, 11.0, 12.0, and 13.0. Okay, time taken, let's say here 3 seconds. Let's say this is 10 seconds. This one is 15 seconds. And then drop to 5 seconds and 1 second, for example. Okay, so pH and times, I don't care. I just simply put in this. Okay, so now the question here is, okay, first I draw if this is a graph given, look at this, this is graph paper given. So first thing, I need to draw the axis, correct or not? Okay, so my axis. Okay, I draw axis. So axis, you have to draw as, okay, can you see that? Left hand side. So this is y-axis. So y-axis will be time taken. So exactly copy it down. Second. Can you see that? I copy. Okay. Now next. For what x-axis also draw a line on a line. Okay. So this one will be pH. So write down pH. Okay. Now, in this case, for x-axis, I do not need to start at 0. I can start from 9 so that I can have the big graph. If I say 0, then I have, let's say for example, 0, and here, let's say for example, okay, 0, 5, 10, 15. pH no have 15, so that's a problem. And why you put 15 in this case, then you can see something weird here because your graph will be less than half. Can you see that? From 9 to 13. All right, so means that this scale is not correct because my graph will be too small. So means that change it. Not correct. So I change to what? Okay, let's say I change it to 9.0 every 2 units. 2 unit can, right? 2 centimeter to 2 unit cans. Okay, so 2 centimeter 9, and then 11, 13. 9, 11, 13. Can you see that? So I will cover more than half already. Can you see that? Are you clear? 9, 11, 13. If you don't want, you can put it as, okay, I can start another one. 8, oops, sorry. 10, 12, and 14. Then also I will cover from 9 to 13. So it actually also big enough, my graph. Can you see that? Are you clear? Okay, yeah? So now you can see that, guys, I use 1 decimal point. Why 1 decimal point? Because the table give me 1 decimal point for pH. And times taken now. So time taken, yes, you can see that now. No choice because it's near to 0. So I put 0 here. Okay, let's say for example, okay, let's say so 0, and we can have 5, 10, and 15. Can you see that? Are you clear? Okay, so that's my graph will be large enough. So here, can you see that why that 1 decimal point? You look at this part. Okay, where's my pointer? Can you see that? Why that 1 decimal point? I use 1 decimal point because the table show me 1 decimal point. So it means that for y-axis, I start from 0. Can you see that how I write it? And x-axis, I start from the 8. Now, don't use it in mathematics. I know that sometimes when they teach you guys to use a jump start, or the jump scale, the jump scale, I mean the symbol, like something like this. No, don't use that. Are you clear? Don't. Okay, then you can draw your graph. Okay, you can put up to 20, doesn't matter. Okay, so your graph must be covered by the scale. Okay, now this one example. Next example, look at this. Let's say I have time and also length in millimeter. Length always in millimeter. Okay, so increase in length, for example. So time at 0 second. Okay, length remains an increase in length. Okay, so increase, no increase in this case. Okay, can I see that? Okay, at 10 second, increase to 5.0 millimeter. Okay, and then let's say 20 second. Okay, increase to 12.0 or 12.5. Okay, and then okay to 30 second, then you can see that now increase to 14.5, for example. Okay, so now when you draw the graph, okay, your x-axis and y-axis. So for y-axis, then we know that x-axis must be time, right? Time in second. Y-axis, so right in full, increase in length. What is the unit? So follow millimeter, and then you use the scale. So the scale here, guys, we do know that we have no choice here. We have both must be in, 0. But again, don't share the 0. Don't share the 0 for x-axis times. So 0. Can I see that? Okay, so 0, 10, 20, 30. Okay, so can or not? Yes, this is considered 1 to 5. Can or not? Every 2 centimeter, 10 units. So 10 units is 1 to 5. Are you clear? Okay, so how about y-axis? So y-axis, so 0.0. Can you see that? Here is very important. Highlight. We don't share, even though both of them start from the 0, we don't share the 0. Can you see that? We don't share the 0. So let's say, for example, in this case, okay, let's say 2 centimeter to 2 units. So 2, 4, let's say like 8, 10. Okay, let's say for example 10, 12, 14. Now, this is a common mistake done by a student. Can you see that I have to plot up to 14.5? So your scale must cover more than 14.5. So it means that I have to add another one, 16.0, only correct. So if you stop it here, then not correct. You have to add another one because you need to cover until 14.5. So you cannot have the scale that lower than your plot. Your plot, you get what I mean here? You cannot. Are you clear? You cannot actually have the scale that less than your plot. Okay, so I stop recording a while. So first thing you look at this, when you talk about the plot, okay, so either you use a cross or dot and circle. So you use cross for the first line. If you've got second lines, then you have to use a dot and circle. And the cross, the line must be thin, as I said that, and the dimension must be less than 2 mm by 2 mm. So when you plot, you have to plot to the nearest half box or half division. So it means that you either plot it as the full or half. So half you need to divide it by 2. Now, for example, in this case, so if pH equal to 10 and my rate is 2.43 RB3 units, so how do I plot 2.43? So look at this. 2.43, I'm going to plot between 2 to 2.5 correct? So this is my lower limit. Okay, so I use my value 2.43 minus out my lower limits 2.00 divided by smallest division. So each smallest division is how many units? So because you look at this 2.5 minus 2, so it means that the divisions here, 10 division is 0.5, so 1 division is 0.05. So you calculate, so tell you 8.5, 8.6, sorry. If 8.6, this is 8.6 box. Can you plot 8.6? You cannot, half box on it. So the nearest one, so it means that 8.5. So you count from the bottom here, You count this 1, 2, 3, 4, 5, 6, 7, 8, 8.5. So means that it will be here, half box. Are you clear? Can you see that? Okay, so let's say, give you another one. If let's say I have 2.28, for example. Now try 2.28. How many boxes I need to plot? Calculate now. Okay, so 2.28. Okay, just now we have the answer 2.28. So 2.28, it will calculate, the calculator will tell you 5.6, but I can't plot 5.6, cannot. Okay, so I only can plot up to half nearest one. So half nearest one will be 5.5. It can be either round it up or round it down, but must be half, nearest half. Okay, so 5.6 cannot. So I put 5.5. So count 1, 2, 3, 4, 5. Cannot. So 5.5 box. So 2.11. If 2.11 you calculate the answer, give you 2.2 box. So 2.2 boxes cannot. Okay, 2.2 cannot. Okay, so nearest one 2. So therefore 1, 2. So plot it at the corner there. This is how you draw for the plot. Okay, so stop recording. So the last mark for line. Okay, so the lines, it must be thin. So how thin is considered thin? So less than 1 mm. Okay, the thickness of the line must be less than 1 mm. And you have to be careful that when you draw the line, this one very careful. It must be, okay. No. Wait, sorry. We have 3 types of line. So what are these 3 types of lines? The first type of lines is a smooth curve. Okay. Second, best fit, straight line. And the third one is the point to point. Okay, you join the point to point. Okay, you join using straight line. So most of the time I say point to point, so understood. Okay, point to point using a straight line. Most of the time I say point to point. So now, first, smooth curve, only use it when you know where is the turning point. Now, for example, okay, so I have 5 plots here. So if you draw like this, okay, sorry, this one a bit like, for example, sorry, let me show you guys another one. So let's say 1 point, 2 point, 3 point, like this, 6 point. Okay, so means that when you draw the line now, this one no problem, but come to this part, this one no problem, but when come to this part now, I have a problem because I do not know. Look at this. I do not know where is the turning point. You may say that, oh, I go here in third. Some may say that I go here, then third. That's that. I may go in this way, third. So you do not know where is the turning point. So in this case, you cannot use smooth curve. Are you clear? You must know where is the exact turning point. For example, when you use it, when I have more plots to tell me that like that's okay, because I know that if I follow, it will be smooth curve like this. Then okay, this one can use a smooth line. Are you clear? So normally we seldom use smooth curve because why? The gap is too big. Generally, I don't say 100%. If you can plot smooth curve, then you have to plot smooth curve. Are you clear? Now, second, best fit line. This is the rare form. Very, very rare we use a smooth best fit line. Best fit straight line, it must be like this, guys. Most of the point located on my line, even some of the point may not located on my line, it must be close enough to touch my line. Then you can use a best fit line. Because in biology, most of the time, later you can see that some of the graph or most of the graph, you can see that they got the limiting factor. So for example, if like this. So you can see that the graph actually is level off, correct? You get a plateau. But if you use a best fit line, then it won't show the relationship of the limiting factor. So that's why I say that very, very seldom we use a best fit line unless you can see that those points actually located on the line or can touch the line. Are you clear? Okay, so this one is not correct. This one, yes. Okay. This one you have to practice more than you will know. Okay. Then the last one, point-to-point joining using a straight line, is the most common one. Most common types of the graph we're going to plot. Okay, this one you will take up by like 95% chance you're going to get correct if you use the point-to-point joining. So it means that if you are not sure which one is smooth or point-to-point, safe side, point-to-point joining using straight line. Are you clear? Okay. So how you draw point-to-point? I want to focus here. This one, point-to-point joining. Always remember, if you draw it, it must be straight line, and you have to from the center of the cross to the center of the cross. You cannot extrapolate. For example, if you extra a little bit like this, wrong. Are you clear? You won't get the mark for the line marks. Are you clear? It must be like, for example, like this. Okay, so my point. It must be the center of the point to the center of the point, and you have to use ruler. It must be a root line. Are you clear? You cannot freehand draw it because it's not a curve. Okay, so with this, you can copy down for this part for the line. Okay,